Intermolecular forces, also known as van der Waals forces. Intermolecular forces are the forces of attraction between molecules, which cause physical changes. Intramolecular forces are the covalent bonds within molecules, which cause the chemical changes. So in this picture, the intermolecular forces are the red dotted lines, and the black straight lines are the intramolecular forces. Intermolecular forces can determine if a substance is a gas, liquid, or solid at a temperature. Intermolecular forces can also determine the viscosity, which is the thickness, the surface tension, which is the film on the surface, the heat capacity, which is the heat energy to raise the temperature of a substance by 1 degree, and the volatility, which is the evaporation. There are three main intermolecular forces known as London dispersion, dipole-dipole, and hydrogen bonding, which increase in strength as you go down the list. Once again, the red dotted lines are the intermolecular forces, and the black straight lines are the intramolecular forces. The first one is London dispersion, which exists in all atoms and molecules. It is the only force of attraction in nonpolar molecules or atoms. Its strength increases as the number of electrons increases, and it is the weakest of the three intermolecular forces. Its definition is that in molecules, the electron density is not evenly distributed throughout the molecule, which creates a temporary dipole which interacts with other dipoles. In the picture at the bottom, it shows the uneven distribution becoming where the positive and negative dipoles attract each other. The next is dipole-dipole forces, which are in all polar molecules. It is known as the electrostatic interactions between the molecules which have permanent dipoles, unlike London dispersion, which has temporary. In the picture at the bottom, it shows the partially negative and positive ends attracting each other. Hydrogen bonding is known as a very strong dipole-dipole. It is the strongest of the three intermolecular forces. It is when hydrogen is bonded with fluorine, oxygen, or nitrogen. It is known as the force of attraction between a hydrogen, which has a positive charge, that is bonded to a high electronegative element which has a negative charge. In this picture at the bottom, it shows oxygen which has a negative charge bonding with the hydrogen which has a positive charge, which results in a hydrogen bond. Lastly, intermolecular forces can determine the boiling points. In covalence, the boiling point depends on the nature or strength of the intermolecular force and its size or shape. By nature and strength, it means one of the three intermolecular forces, which are London dispersion, dipole-dipole, and hydrogen bonding. The size and shape means that the elongated molecules have the highest boiling points. So in general, stronger forces have higher boiling points. In this picture, it has London dispersion forces as the lowest boiling point because they have weaker intermolecular forces. And it goes all the way up to the highest boiling point, which is hydrogen bonding, which has the highest intermolecular forces.